Okay, you can hear me, right?
Yep.
Yeah.
Okay, cool. Okay, hello everyone. Welcome to the KDD2020 tutorial on recent advances in multimodal education data mining in K-12 education. So I'm Zitao Liu from TAL Education Group, and also we have a few wonderful organizers. Dr. Songfan Yang, also from TAL Education Group, and Professor Ji Liang from Michigan State University, and Professor Niu from WPI, and Professor Rose from the UCL Knowledge Lab. Okay, so this is the outline for today's tutorial. So the first part is we will talk about the future of education in the 21st century. So AI has changed almost everything in our life, and it's changing the part of the education. So we will see what have been done in the past and what is going to be done in the future. Second part is AI in K-12 education. So here we will focus on a few bunch of very cool and recent AI applications in K-12 education. And third part is about the multimodal learning in education. So in the third part, we will split into two parts. The first part is we will go over some hardcore machine learning techniques on educational representation learning. And the second part, we will go over how do we use the general data science and machine learning to do the algorithm assessment and evaluations. And the last part is the conclusion and the future, the future work. Okay, so the first part, the tutorial instructor of the first part will be Professor Rose Lakin. So Rose is a professor of learner-centered design in UCL. And Rose is quite famous in the education domain. And she's one of the 20 most influential people in education. And also she's the co-founder of Institute of Ethical AI in Education, the director of Educate London. And also Rose is the president of the AIED. Okay, and I will talk about the second part and the half of the third part. So I'm Zitao Liu from TAL Education Group, and I together with my team we created the TAL AI Open Platform, so everyone can access and use the AI technology we built for education. And the third instructor is Niu. So Niu is a professor of computer science at WPI, and Niu is also the director of the Learning Science and Technologies graduate program. And Niu have his famous assessment, the website of the tools, and he will talk about that later in the part 3. Okay, so the first part is I will handle the presentation. I will pass the presentation to Rose, and she will talk about the first part, future of education for the 21st century. Okay, I will stop my sharing. Rose, you can share your screen.
Okay. Oops, let me just get the presentation up. You don't want to see my email. Whoops, there we go. Yeah, is that right?
And by the way, this is Neil. And someone actually said, will this be recorded? Zitao, are you going to record it?
Yeah.
Excellent. Good.
Yeah.
Excellent. And it's good that we record it after we actually get Rose's email not to show up.
Yes.
Take it away, Rose.
Thanks, Neil. And thanks, everybody. Yes, I'm going to do a lot of context setting, really, to think about, because many data mining, machine learning techniques can be very important for education, but what is the future of education in the 21st century? And I think in order to appreciate the future, you need to just have a little look at the past. So I am going to talk about AI in very general terms, thinking of it as technology that's capable of actions and behaviors that require intelligence if done by humans. So very, very general definition. There are many, many more detailed definitions. And of course, we can already see many, many applications of AI in education, whether it's bots in university life or whether it's children in primary schools being taught about robots, being taught about AI. But where did it all start? And I think it's really important to look at where it all started, to think clearly about the future. And I looked, because a lot of people associate the word AI with the word robot. I had to look to see where I could find the earliest use of the word robot. And the earliest use I could find was in a play by a Czech playwright called Karel Capek. And he had a dystopian future play with these people dressed up as robots. I think everybody on that screen looks a bit robotic. But the point of showing this is to remind us that at the moment, we very much look at developing AI systems that can look and behave like humans. But in the early days of thinking about robots, it was very much about people pretending to be robots because we didn't have any real robots. And I think we need to be careful in education that we don't end up in a situation where we are encouraging people to behave like robots. And I'll say more about that a little further on. So it all really started, modern AI that is, in 1956 in September, so next month, 1956, so that'll be 64 years ago there, in a meeting in Dartmouth College in New Hampshire in the USA, and 10 scientists gathered together for a couple of months over the summer and believed that it would be possible to describe every aspect of learning or any other feature of intelligence in a way that was so precise that a machine could be built to simulate it. And I think that sounds crazy now, but that was very much what people thought could happen. And I would say that's because we vastly underestimated how enormously complex human intelligence is. Another couple of key characters, I think, you know, from a robotics point of view, it's Norbert Wiener, the forefather of, or father of cybernetics, and Alan Turing, the famous mathematicians, who really introduced the idea of the Turing test, which was the test of whether an AI system could fool humans into believing that it was a human. And people still take part in Turing tests today. And when I interact with bots on a website or any other kind of application on my phone, I'm always reminded of one of the very early AI systems called ELIZA, which was a text-based interface, which is the kind of thing that was being used in the 60s. And ELIZA pretended to be a psychotherapist, and you could ask ELIZA questions, and ELIZA would try to come back with a text answer that was appropriate. But these systems were based on a set of rules, not on machine learning. And so the system fell over very quickly. And you can see at the end of this little example that the human says, because he's spotted that really this conversation is not going anywhere, and says, you know, now you're just talking nonsense. And the ELIZA system comes back with, what makes you believe now I am just talking nonsense? And that's because of this pattern matching. ELIZA has looked for a rule that she can match to the kind of statement that's been made, which is, but you're just talking nonsense. So these were very brittle systems, but actually a lot of people were fooled by them. And I find many of the bots one interacts with today not that much more intelligent, to be frank. And these rule-based systems were actually quite effective. They led to a whole range of expert systems in the 80s that were responsible for some very useful systems, looking at medical diagnosis, for example. And one of those systems, MySyn, was also very influential in my mind for helping us understand about how we need to make AI explainable. And certainly this was an approach that was used in education, one of the very early systems, and you can see that publication dated 1978, which was a diagnostic model to try and understand very basic procedural skills, errors.
The target data domain, we don't have any label data. So the idea is actually we try to make the
now I can hear somebody else speaking.
Yeah, let me mute them.
Okay, that's lovely. And so this was an example where we were trying to diagnose the errors that young children make when they're learning basic arithmetic skills by building a model that not only had the correct rules, but also some buggy rules so that we could provide better support. So a lot of these systems were built in the early days on this rule-based approach. And actually the screen here is a system that's been developed into something extremely successful, but started off being based on very much a rule type of AI. And those early systems that were used in education were really a form of intelligent tutoring system where you had a model, a knowledge representation of a particular domain, maths in this example. You had a model of the learner, i.e. how much you believed that that learner understood about maths, a pedagogical model, and a model about how you should apply the rules, how teaching should be done, an interface, and the student interacted with that interface. And we've come a long way since this time, but nevertheless, there's still many systems that use, even if only in part, use rules to create some useful personalization or adaptation. But some famous game-changing moments, I remember when I was studying for my PhD, this particular point in the game when the IBM system Deep Blue demonstrated its prowess at chess by beating the then chess grandmaster Garry Kasparov. And I remember, you know, I was working in an AI department at the time, and people were very excited about this because people thought, well, chess is played by intelligent people. Hey, if we can build a machine that can play chess to this level, then we must be able to do some great things with AI. And this was all based on this rule approach. But actually, it wasn't long before people realized that actually things like being able to see vision is much harder than playing chess. And we then realized that we weren't actually close to creating a really generally intelligent machine. And then, of course, the moment that you'll all know about, when AlphaGo beat Lee Sedol. And of course, this was deep learning and machine learning. So we know that we can build systems that can not only play games to a very high level, but systems that can learn and improve and improve and improve. And of course, it's not just in game playing. It's also in many, many useful areas such as autonomous vehicles and medical diagnosis, lots and lots of very useful systems being developed. And I think there's 4 things that it's important to remember. The autonomy of the AI system, because it's able to perform tasks in complex environments without constantly having to go back to a human. And adaptivity, the ability to improve performance by learning from experience, which of course is how humans learn. But the way machine learning happens is not precisely the same as human learning. But that adaptivity can be really useful when we're building AI systems to help people learn. And we need to, of course, differentiate between narrow AI, AI that can do one thing, which is where we are now, and artificial general intelligence, where we have this dream of a machine that can do all of the things that we as humans can do. So whilst at the moment we're at the stage of having a machine that can play chess or drive a car or diagnose an illness or be able to recognize images of specific things, and yet the consultant in a hospital who can conduct the medical diagnosis can probably also play chess, also drive a car, also recognizes images. And we don't have AI that has that general kind of intelligence yet. And personally, I'm not a big fan of believing that AGI is really possible. But my real reason for that is that I believe that there's a huge difference between human intelligence and artificial intelligence. And we really need to start recognizing that difference. And that's what the future of education with respect to AI really needs to focus on. So if I think about intelligence, human intelligence, I see it as a very complex, intertwined concept that is made up of these different elements. These are not separate intelligences, they're different elements of a very complex whole. And we have interdisciplinary academic intelligence that's extremely important, as we need different disciplines to be able to talk to each other. So if I'm an expert in physics, it's really useful if I can talk to experts in medicine, and that's how nuclear medicine, you know, has come about and become such a force in diagnostics and treatment. And meta-knowing intelligence, and this is very much about understanding what knowledge is, what it comes from, why should we believe something is true. And so it's about understanding data and evidence that should persuade us either to believe something or not to believe something. and social intelligence that we as humans can be very good at and is increasingly important, because the complex problems that we face today can rarely be solved by one individual. We need people to be capable of complex collaborative problem solving. And then a set of intelligences that, going along with meta knowing, are really about meta intelligence, about self-understanding. So metacognitive intelligence is about being able to understand, regulate, control aspects of our thinking. So self-regulation in learning is extremely important and is a good example of this. Metasubjective intelligence, which is about not just being emotionally intelligent, but being able to understand accurately how our emotional intelligence is developing, how the emotional intelligence of the people we're working with is or is not developing. So it's being able to stand back and really understand, and to an extent try and control that development. Metacontextual intelligence, something I think we underestimate at our cost, and we underestimate a lot of the time. It's relatively simple for us to move between different environments, physical and digital, virtual environments. It's easy for us to move into interacting with different people, with different kinds of resources. And we can do it often without really being aware of the change that's happening. It's just part of the way that we are. But it's incredibly difficult for AI systems to do that. And I think it's part of our intelligence we don't pay enough attention to. And then the kind of gold when it comes to learning, this idea of perceived self-efficacy, and in particular accurate perceived self-efficacy, where we as humans are capable of setting our own goals, of making good judgments about how likely we are to be able to achieve that goal, what we need to do in order to achieve that goal, what we need to learn, what we need to understand, what other resources we need to pull together. And that might be people we need to work with, it might be technologies. We can do this, but we need to develop all of these elements of our intelligence to a sophisticated level in order to get to that point. Now, currently, AI really has only made considerable advances in the areas of interdisciplinary academic intelligence, meta-knowing to an extent, social intelligence. Some would argue that AI can be emotionally intelligent. I would disagree and say that we can simulate, but there is no real empathy, there is no real understanding of emotions and feeling those emotions. So really, we need to think about our education systems focusing on the parts of our intelligence we can't automate rather than the parts that we can. So we end up in a world where the AI and the human eye work together in a complementary way. But at the stage we are at the moment with respect to AI and education, we nevertheless have some very smart tools available to us. And I know Neil is going to talk later today about an extremely good system called Assessments. But I'll give you just a few examples of the kind of current state of the art out there being used actively in classrooms at the moment. This is a system called N-Skills, developed by a company in the US called Alelo, and it's a conversational agent with whom you can hold a conversation as you learn to speak and understand English. And so wherever you are in the world, you can open up a browser, and as long as you've got an internet connection, you can have a conversation with this system, and it will interpret what you're saying and respond in an appropriate way, individualized to what you need as a learner of English. And there are many systems, examples from Carnegie Learning and from Century Tech in the UK, where we have really good quality adaptive systems that can take an area of the curriculum and provide support and activities that are very tailored to the needs of an individual learner. And that can be extremely useful, and well-designed systems like this can perform as well as a teacher, a human teacher, when that human teacher is interacting with a class of students. We can't yet build systems that can tutor as effectively as a human tutor working on a one-to-one basis, but hardly any learners ever have access to that. So these systems can nevertheless be very useful. And then there's a whole range of other AI systems used in education that are versions of recommender systems that are really recommending resources to you as you are the learner, or indeed recommending resources to you if you are the teacher that are good for your students to use as they're learning about a particular subject that's the focus of their attention at the moment. So these systems don't tutor or teach, they provide resources. Although Volley is a slight exception to that. Within the training world, Volley doesn't just find resources, it collates those resources into activities, but it's still not a tutoring system. And just in case you were thinking that AI for education is only for adults or for school-age learners or students at university or college, no, absolutely, it can start very young. This is an example of an AI system that's developed for use with very young infants who are learning to talk. So it's designed to help with their language skills, and the little cloud-shaped monitor sits in the infant's room and monitors any verbal interactions or any audio between the infant and others, sisters, brothers, parents, and then sends information back to the parents to give them guidance and advice about how to help their young infant develop their language skills. And as far as I know, this is only available for English at the moment. And lastly, it's not just about using AI to focus on particular areas of the curriculum. We can also have systems that can help us develop what you might call cognitive fitness. So this is an example of a system called MyCognition that helps to develop your general executive function, your ability to pay attention, your memory, both short-term and long-term. And it uses a little bit of AI to adapt the way that the system interacts with you to try and meet your individual needs. And the system does an initial diagnostic test, and then you play a game called Aquasnap, and as you play this game, the system adapts to try and improve the areas of your cognitive fitness in order to improve those areas. And it's a very useful little tool. It was originally developed as a medical tool and available on our UK National Health Service to help people who were at risk of depression. But it's also been tested and found to be very effective in educational applications. But I think the real interest and the excitement for AI is in the potential. The systems that exist today are useful, and those that have been well designed and well thought through are particularly useful. But really, for me, it's the potential that's really exciting, because, you know, the reality of where we are now in the world is not only are we coping with the coronavirus pandemic, but we're also quite well into the early stages of the fourth industrial revolution. And we certainly need to think about what that means for humans. Now, there have been a lot of reports, examples of some of the charts in those reports on the screen now, that have looked at what does this mean for the workplace? What kind of jobs are going to be the first that will be lost? What kind of skills do we need in the workplace? What should we be doing to help people develop these skills? But in the main, these reports are not necessarily very consistent. They're certainly consistent that people with a good education are less likely to be at risk. And there's some consistency about the way in which storage and some areas of manufacturing are particularly, and transport are particularly at risk. But actually there's a lot of differences between the different reports that have been produced. And I think perhaps that's because we're asking the wrong question. I think we need to see the situation we're in now, and made even more so by the pandemic, as being a little bit like driving a car in very thick fog along a road that you've never driven along before. And in that situation, a map isn't actually terribly useful. And those reports are very much trying to produce a map. I think what we really need in this situation is to know that we've got a reliable car with good steering, that we've got good lights, that we've got brakes that work, that our tires have a lot of tread on them, that as a driver, we know how to drive, we're not under the influence of alcohol, we're not sleep deprived, we can see well, we can hear well. These are the things that are actually far more important in that situation. And so the equivalent of that sound car and sound driver, I would suggest, are these ways of looking at our complex human intelligence and thinking about how we develop these as we move forward with AI and its use in education. Because as I say, really our AI systems can only tackle some of the elements of our human intelligence. So we really need to learn how we focus on the elements that we can't automate, as well as some aspects of the elements that we can. And so I stress, it's not separate intelligences, it's an interwoven, complex whole that's made up of different elements. And 5 of those elements are about meta-intelligence or self-understanding, whether it's about our thinking, our emotions, about the different contexts that we operate in, or it's about that really valuable understanding what knowledge is, where it comes from, what evidence is good that should make us believe something to be true or not. And if we get that right, then we really can become very accurately self-effective, very good at learning and performing in the world. And this can complement what we can do with our AI. And I think one of the really interesting finesses about the situation with respect to the 4th Industrial Revolution is that the reason that the 4th Industrial Revolution is happening is partly because we've built very smart AI systems that can learn and that use data in order to learn. And so we think of data as being the new oil. It certainly makes a few companies very wealthy, so it's similar in that respect. But it's also similar in another important respect. Oil is crude until we process it, and so is data. And we need to make sure that we process the data available to us to help us build the kind of educational AI applications that will really help us to build those important elements of our human intelligence to much more sophisticated levels. And in order to do that, we need to understand something about human learning. It's not just the machine learning, it's the human learning that we need to understand so that we can develop our machine learning algorithms and choose wisely from the data that we have to help us understand and monitor and track our advanced human intelligence. I will give you one very small example in the last few minutes of this presentation. This is some work that we've been doing where we look at students who are taking part in collaborative problem solving. And we can, of course, monitor where they're looking, we can monitor where their hands are, we can look at what they're saying, we can look at the interactions they're having with technology. All of these things can be collected. But actually, on their own, they're a bit of a mess. And what you really need is to look at what we've understood about human collaborative problem solving, about human learning, and use that to inform the way that you build your machine learning algorithms to process this kind of data. And I'll give you one very specific example. There's some nice literature, research literature from psychology that demonstrates that actually synchronous eye gaze and synchronous hand movements are associated, it's only a correlation, are associated with effective collaborative problem solving. Now that's not to say that if you're looking in the same place and your hands are in the same place, you're necessarily effective in your collaborative problem solving, but it's one small signifier. And there are many of these signifiers that we can identify from learning sciences research and use to design machine learning algorithms. So in this instance, we did indeed do that. And we had a human watch the video and audio of groups of students collaborating, and at certain intervals say whether she thought that this group of students were taking part in effective collaborative problem solving. And she was an expert in the field who was not associated with the research. And then we also ran our machine learning algorithm over the data that came in about eye gaze and hand movements. And in this chart, you can see that in groups of 3 students, where the human expert had rated this moment for this group as being effective, high collaborative problem solving, the lines across the screen being closer together indicate that our machine learning algorithm also identified synchronicity in hand and eye gaze. And when the human suggested there was low collaborative problem solving, again, we get a much greater spread, so less synchronicity between the different students. It's one tiny signifier. But if you can imagine lots and lots of multimodal data, i.e. data that captures all the modalities in which we interact, and good AI algorithms that have been designed in a way that takes account of what we understand about human learning. In that example, what we understand from psychology about synchronous action. And you combine that together as an infrastructure like electricity that can power all our interactions. And then importantly, you meld that with human intelligence, the human intelligence of teachers who can interpret what the algorithm is saying and help learners to understand what that algorithm is saying, and parents and employers too. So it's an infrastructure that combines artificial and human intelligence. And if we can use this to power all our learning interactions, whether it's virtual reality, augmented reality, learning with your phone or computer, or just simply learning on your own, because you understand more about yourself as a learner, you can be more effective at learning. And if you want to know more about this, I wrote a book a couple of years ago called Machine Learning and Human Intelligence, and that goes into detail about that interpretation of human intelligence and gives different pieces of evidence and research as to why I believe we can think about human intelligence in that way. And also we have free webinars available at that website on AI readiness, which we've been working on with businesses and educators for a while. But I hope that has set the scene for what's going to be a great day. Some wonderful presentations to come up. So I'm going to thank you for listening to me and pass over back to Untitled to take us to the next step in this tutorial. Thank you.